Hello everyone, hope everyone is doing well. Today in this lecture we are going to learn about indifference curves. We are going to see how they are derived and what can we do with them. So indifference curves, basically before we learn about indifference curves, we first have to talk about something that we call preferences. Now preferences here, as we talk about it, it's basically what we like more, what gives us more satisfaction or utility, or what gives us less satisfaction or less utility. So usually it's compared between two goods. Let's say we have two products. We have apples and oranges. Now, if I ask, let's say 100 people, which one do you prefer, apples or oranges? Some people will say they like apples. Some people say they like oranges. Now, that's an individual preference. If somebody likes oranges, I cannot convince them maybe to like more of apples, and vice versa. Let's say apples are denoted by A and oranges are denoted by B. So in this case, we can say that maybe, let's say person A, like Chris here, Chris probably prefers A to B. So if I give Chris one apple and one orange, Chris is going to prefer the apple. On the other hand, we may have another person, Tom, on the other hand, let's say prefers oranges to apples. So Tom may prefer an orange if I offer Tom both an apple and an orange. Now, what does this mean graphically, or when we come to economics? So in our case, let's say I have an income. I earn, let's say $100 a week. How am I going to spend that money? So I would like to buy only those products that I prefer. So if, let's say we live in a society where there's only apples and oranges, then if I'm Chris, I would rather just buy apples and no oranges. On the other hand, if I'm Tom, I would rather buy only oranges and not apples. So this then helps us in understanding individual decisions. If a person gets a certain amount of income, how do they spend their money? So just like many things in economics, we use a graph to understand preferences. So let's say here we have a graph. We have maybe apples in the vertical axis and number of oranges in the horizontal axis. Now, let's say I'm just talking about Chris here. Chris, we know, prefers apples to oranges. So let's say we have a certain bundle here, and we go from, let's say we have 1, 2, 3, 4, 5, 6 apples. And same here, we have some number of oranges. Now, let's say I have a bundle here, where there is 2 apples and 1 orange. Now, in this case, this is the amount given to Chris. So let's say this is bundle T. Now, it is given, we understand from here that if I give Chris, even though Chris doesn't like oranges as much as apples, if I give Chris more apples and more oranges, Chris would like that. So let's say we have another bundle offered here. Let's say this is 3 apples and 3 oranges, and this is point Q. From here, I can see that Chris will definitely prefer Q to T. So even though there is more oranges in that bundle, because there is more apples, Chris is going to prefer Q to T. Q, okay, so Q is definitely preferred to T. I can see that since Q is preferred to T, if I move to another point, let's say to a point like here, this point has definitely more of apples and more of oranges. So this point R is also preferred to T. So I can also write R is also preferred to T. Same thing with up to, I can go all the way up to this point, and it seems like, well, let's call this point S. I can see that S has more apples, less oranges, so S is also preferred to T. Same thing goes with all the other points here. So I can create another line here, and I can definitely see that any points in this quadrant is going to be preferred to point T. Now let's look at another side. So let's say we have a point up here, and this is my point T, and we have just established that every point in this quadrant here is preferred to point T. So we know that. Now what about a point like this? What about a point when, let's call it M? Now M has less of oranges and less of apples compared to T. So from here we can see that T is preferred to M because here M has less of both. So by that logic, we can go draw another quadrant here. So that means any point in this quadrant is not going to be preferred compared to T. So from here, we have established that in this quadrant, all the points are less preferred to point T. Now in this quadrant, all the points are more preferred than the bundle T. Now what about these two areas? This creates a bit of an issue because, well, in this point, I know that Chris likes apples more than oranges, but I don't know by how much. So does Chris just hate oranges and just loves apples? Or the Chris is like, yeah, apples are okay, are better than oranges, but only by slightly. If I have 5 apples, I might have 1 orange. So we don't know the degree of substitution that Chris likes between apples and oranges. So we really cannot say, and this is where we know that the points become a little fuzzy here, is that we don't know if this point, let's say point K, is this better than T, or point R is better than T. This is where it depends upon the individual. So after we kind of fine-tune, we have to ask them, give them different bundles and like ask them, okay, this bundle has 3 apples and 3 oranges. What if I give you 4 apples and 5 oranges? Whoa, would you prefer that to T or not? And so based on that, we can figure out certain points, maybe points here are preferred, points here maybe are not, and vice versa. So then we draw, and then we end up drawing a line that kind of goes like this. And this line has a name. We call this line an indifference curve. As the name suggests, the lines on this point, so if we have these points, these are points where Chris is indifferent to the bundle. So let's say we take point T and this is point V. So point T has 3 apples and 3 oranges. Oranges are, as we said, is point B. And point V has 2 apples and 5 oranges. So if Chris were given either bundle T or bundle V, Chris would be happy either ways. So points on this line make Chris indifferent or equally happy. So then points here, let's say point K, or I'm running out of letters here. Let's say point F here. Now we can say that if Chris is indifferent on this line, then point F is less preferred than point T. So we can then say that same if we have a point here, point N is then, we can see this point is higher than the indifference curve. So we can see that Chris here prefers bundle N to bundle T. Such a line helps us to understand what a person likes. If a person is given different choices, which choice are they going to take? And this is completely up to the person's preferences. Some people like this. Maybe this is their indifference curve. Another person may think that this may be their indifference curve, or another person might feel like this is their indifference curve. It depends upon how much they prefer apples to oranges or vice versa. For every point, as we have seen, then we can say that. So again, let's start with apples and oranges. So let's say we have an indifference curve, I prime. Now for the same person, therefore, if I take another point, I can see that this bundle point, let's say this is point S. Point S is definitely preferred to every single point on the line I prime. So the bundle S is preferred to every point on the indifference curve I prime. So if I did the same exercise as before, I can see that I can draw another indifference curve that goes through S that I can say is I prime prime. So the fancy way of showing if something is preferred is a squiggly greater than sign like that. I would then say I prime prime is preferred to I prime. So then this indifference curve, every point on I double prime, the red line, is preferred to every point on I prime. So thus, if I move outwards, I can see that I double prime is more preferred than I prime. If I go downwards, let's say here, then I can say that I prime is definitely preferred to I, and so forth. And so if I is preferred to I prime and I double prime is preferred to I prime, then I can also say by the law of transitivity that I prime prime is preferred to I. Since we have to follow transitivity here, now if I have for the same person, I cannot have an indifference curve that, let's say, is I prime, but then the other indifference curve goes like this. And the reason is, okay, these 2 points are fine, but then what if this line and this line intersect? That means that, let's say this is point K. If they're both on I prime prime, let's say I have a point L here, then K and L are basically indifferent points because the person, it's on the green line, so K and L are basically, the person is indifferent to those. But K is also on I prime. So if I have another point, let's say point M, that means I can also say that K and M are indifferent, which would then mean that L and M are indifferent too, because by the law of transitivity, if K is indifferent to L and K is indifferent to M, then L and M must be indifferent. But I can see clearly that M is on a much higher point than L, and I can see that M has to be preferred to L. So then, for the same person, we can never have indifference curves crossing like that. So indifference curve either move up or move below. Now we have certain kinds of indifference curves. Of course, we have indifference curves. This is the classic style that we have. And if I'm at, let's say, point L, now I know that point L and point M are basically giving me the same amount of satisfaction. Now, if I want to move from point L to point M, let's say I'm initially at point L, I have to move to point M, what do I have to give up? So I need to give up this much of apples to get this much of oranges. So here we come up with a formula, and we call it the marginal rate of substitution. So marginal rate of substitution is how much of the product, let's say of apples, do we have to give up to get more of oranges so that we are as happy as the previous bundle. So we're giving up apples, we're getting more oranges, we're moving to point M so that we are as satisfied as what we were in L. Well, marginal rate of substitution is very similar to the slope. As we can see, we're giving up one product and getting more of another product, so MRS will be equal to, so MRS here is delta y over delta x. So how much of L did we give up, or how much of A did we give up in order to get more of x? Now, to get a finer one, in some cases what we have to do is, in order to get a proper one, because sometimes this line is curved, we have to draw a tangent like this, and then find the slope of this tangent in order to find rate of substitution for point M. So this is telling us that if I give up 1 unit, if I want to get 1 more unit of B, or oranges, how much of A do I have to give up? And as you can see, it changes as we move along the line. If down here, I can see that the slope is almost horizontal. I'm willing to give up a lot more oranges in order to get just a little bit more of apple. Because I have so many oranges, I just don't want them anymore. I may give up a lot more to get just a little more of apple. Same thing with here. Up here, I can see that the slope is going to be, let's say like that. Here, I can see that the slope is going to be a very large number, which means that since I have a lot of apples, I'm willing to give up a lot of apples in order to get slightly more oranges. And this is what we talk about is the marginal rate of substitution. Now, for the most part, we may have indifference curves looking like that. However, there are two special cases of indifference curves. The first one is what we would call complements. Complements are products that go well with each other, so we want them in a specific ratio. Let's say in this case, A is coffee and B is creamer. And if I'm a certain person, I may want a specific ratio of creamer and coffee in my coffee drinks. So I may want, let's say, A is in cups and B is in tablespoons. So maybe I like 1 tablespoon of creamer in my 1 cup of coffee. So then the ratio is 1 to 1. Now if I have 2 cups of coffee, I want exactly 2 tablespoons of creamer. I wouldn't want 5 tablespoons of creamer in it. So now from here I can see that it goes the same way that points up here in the first quadrant are preferred to this point. Points down here are not preferred. So we definitely have this going on here. These are preferred. And then points down here are not preferred. Now what about points on the other two sides, like here and here? So in those cases, I can see that, well, let's take a point here. This has less coffee, this has more coffee, but not enough creamer. So technically, I don't like this point because I want my creamer and coffee ratio to be exactly 1 to 1. Points here too, I can see that I'm getting more creamer, but less coffee. I don't like that either. So complements then have a L-shaped indifference curve. And they all go through that point of the ratio. Now some people may have different ratios. Some people may like 2 tablespoons of creamer to their 1 cup of coffee. So for them, it will be the same shape, but move to a different direction. So for complements, this is what their indifference curves looks like. And it goes the same way. Well, a point here definitely is preferred to the red indifference curve at the bottom. But this is telling me that I actually prefer this indifference curve more than this point here. So this is complements. The other one we have is substitutes. Substitutes are things that may serve the same purpose, so we like either or. So maybe it's tea and coffee. Some people are indifferent to tea and coffee. As long as they get their caffeine, they're happy with it. We don't mix our tea and coffee together and make a drink. Maybe a few people like that, but for the most of us, we prefer either tea or coffee. So for those, they either want all tea or all coffee. If I'm given only 2 cups of tea or only 5 cups of coffee, I'm indifferent with it. So for that, the indifference curve will look like this. A line that goes between 2 and 5. So any points below that are not preferred. Any bundles above here are definitely preferred to this. So for this point, they will move. If I want to move outwards, they move parallelly outwards. And the slope is the same as I move outwards. So this is the indifference curve for substitutes. So substitutes here then tell us if I am given a certain number of cups of tea or coffee, I prefer either one or the other. And of course, our MRS is given by the slope here. In complements, the MRS is a little odd because we cannot really find their slopes, but we know this ratio, and so the ratio is needed in order to draw those indifference curves. Hopefully this was helpful, and I will see you at a later lecture. Have a good day. Goodbye.